The last thing we discussed was how to explain, how to give a meaning to inductive and capacitive reactor. I told you both of them has to do with so inductive reactant is when only inductor is used as a regulator in a circuit. This is an example of a circuit in an inductive reactant. Then we also talk about capacitor, and this is the equation representing an inductive reactor. Should you want to calculate, you use this 2 pi Fl, where L is inductance, F is the frequency, and then pi is very common to us. Then if only capacitor is used, then it is called capacitive what? Reactance. Now, capacitive reactance can be generated or can be obtained using an equation I have the. So if only one of them is used or both of them are used, it's still called what? Reactance. So reactance is when only capacitor is used to regulate, or only inductor is used to regulate, or both of them are used to what? Regulate. Now, I am done with this, I am done with this, I am done with this. So let's look at this. When the three of them are used, meaning resistor is there as a regulator, capacitor is also there in the circuit as a regulator, inductor, this symbol for inductor, is also there in the circuit as a regulator. Such a circuit will produce what is called what? Impedance. Now, by definition, in impedance, it is only resistor that is very important. It can be resistor and any one of them, and it can be resistor and both of them. But resistor must be there because the definition is overall, and we don't say regulation is overall in the absence of a what? Resistor. It is only when resistor is part of the regulators that we can say that regulation is what? Overall. So definition for impedance, now I'm going for impedance, is that overall regulation. Overall what? Regulation. Now, offered to an AC circuit by resistor and capacitor, or resistor and inductor, or resistor and capacitor and inductor. Look at that regulation. This is the overall regulation offered to an AC circuit by resistor and capacitor only, or resistor and inductor only, or resistor, capacitor, and what? Inductor. If you look at that definition very well, you can see that it is only resistor that is constant. The two of them are not constant. It can be resistor and any one of them, and it can be resistor and what? Both of them. Now, if you look at the diagram very well from A to Z, there are some certain things we need to explain here. You can see A stands for ammeter, V stands for what? Voltmeter, and here is the current supplier or current source. Now, if you look at it all through, you will always see that ammeter is connected in series to the supplier of the current in each of the cases. Series means end to what? End. You can see from the end of the current supply connected to the end of what? Ammeter. Here to end to end, here to end to end, here to end to end. Why? Ammeter must always be connected in series to the current supply. And the reason in science is that ammeter is measuring current. So if ammeter is connected in series, ammeter will measure that current directly. Ammeter will be able to measure that current what? Directly. And that is the reason why ammeter must be connected in series, because we need that ammeter to measure the current directly from the current supplier. Nothing must block the ammeter from the current what? Supplier, so that you're able to measure that current directly. And ammeter is always designed to have a low resistance, so that more current can be taken from the current supply. These are the characteristics or properties of ammeter. Every ammeter must be designed to have a low resistance. Why? Because it's taking current from the supplier, so that you're able to take enough current from the what? From the supplier. Now, voltmeter is always connected in parallel to the current supply. What is parallel? Side by what? Side. You can see that the end of here of the current supplier is not connected to the end of the what? Something has come in between what? In between them. So this is called parallel. And why voltmeter is connected in parallel is because voltmeter is not measuring current, and we don't need enough current in the volt, and that's why voltmeter must be designed to have a high resistance so that you will not be taking more current from the what? Supplier. So in each of the cases, if you are drawing the circuit must be drawn like this, where ammeter must be connected in series with the supplier, and voltmeter on the other hand must be connected in parallel with the what? With the what? Supplier. Now that is about. Now what is the formula for impedance? Symbol for impedance is Z, because it is overall regulation. Z. So we can have it as square root of R square plus square root of inductive capacitance. I have told you that impedance can be resistor and one of them. So if I have in the circuit, I have only resistor and one of them, and that one of them is capacitor. So this is how we get the what? Impedance. Impedance can as well be square root of resistor plus square root of. So that is, if in the circuit I am using only resistor and inductor as our what? Regulator. So impedance can be for this. Impedance can be. Now, if the three of them are used now, then I can have general for impedance. So this is the first one for impedance, when only resistor and capacitor are used as regulator. This is the second case for impedance, when only resistor and inductor are used as regulator. But this is a overall, when the resistor and both of them, look at how you relate both of them, are used as regulator. So we continue from the next class.